MAP4C, day 58. Today we're going to be cleaning up our investigation from yesterday, making sure that we have those skills solid about evaluating expressions involving fractional exponents. Then we're going to push that further to solve some equations involving fractional exponents. So that's the plan for today. The 3-minute review we can see is questions that we did at the end of yesterday's class and will be the focus of today's class as well. Write a radical expression, evaluate using without a calculator. So we saw yesterday that fractional exponents meant roots, right? So we write this as a root where the bottom is the root and the top is the exponent. And then I can do this without a calculator. The square root of 49 is just 7. The exponent 1 is just 7. So this answer is 7. No calculator. No calc. 27 to the exponent 2/3. Well, I know it's a root. Fractional exponent means roots. The bottom is the root. The top is the exponent. I always do the root first to make it easy to do the exponent. And these are all things, when you're asked to do it without a calculator, it's going to be something that's easy to do. So some number times itself 3 times, that gives you 27. That's 3 squared. 3 squared is 9. In contrast to that is the next question, which is a calculator question. It says write as a rational exponent first, then use your calculator to evaluate. The idea here is some people might be okay writing these roots in your calculator. Remember this, the anything root button is probably that on most calculators. On the graphing calculator, you have to hit the math button, but sometimes it's just a lot easier thinking of this as a rational exponent. To the exponent 5/7. The exponent is the top, the root is the bottom, and then now in my calculator I'm going to put in 2.063, hit my exponent button, or this one on a graphing calculator, and then bracket 5 divided by 7. We were practicing this yesterday in our investigation. You pound that into a calculator and you get about 1.6774. And make sure if you're having trouble putting this sort of thing into your calculator that you ask. Okay, ask during class. Get that straightened out. On to the lesson. Rational exponents. Evaluate expressions and equations involving rational exponents with and without a calculator. So yesterday we were doing this, not this. So this is new today. Ding, 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 ding. That's new. These were the 2 rules. These are the 2 new exponent rules for us this chapter and this year. Fractional exponent means roots, right? When it's a 1 on the top, there's no exponent out here. But when it's not, when it's m over n in the fractional exponent, remember the bottom means root, the top means exponent. The top is the exponent, the bottom is the root, and that allows us to evaluate these fractional exponents pretty quickly. And I'm doing this without a calculator and showing steps. This is a big thing because otherwise I'm thinking you're just putting the numbers into your calculator. So it's important for you to show that you know what the fractional exponent means. So we know fractional exponent means roots. The bottom number is the root, the top number is the exponent. The cube root of -125, cube root of a negative is possible. Square root of a negative is not possible, but a cube root is possible because I'm looking for something times something times something, and the answer is -125. Well, as long as this is a negative, negative something times negative something times negative something gives me -125. That will work, and in fact it's 5, isn't it? As long as these are all multiplied. And that's the answer. I can do some decimals, nice ones at least, that are square roots. So the bottom number is the root, the top number is and we just have the square root of a decimal. Now notice that every decimal in a multiply questions ends up showing up in the answer. So for instance, if I had 0.2 times 0.2, that's, well, 2 times 2 is 4, but there's 2 decimal places in the question, so there's 2 decimal places in the answer. 2 decimal places. Now, thinking the other way, every 2 decimal places underneath the root leads to 1 decimal place outside. So I'm going to have one decimal place outside. I just got to figure out what the square root of 9 is, and it's 3. Square root of 0.09 is 0.3. Check it on your calculator. This is more typical. This question is more typical in our chapter. Is 32 is a power of 2. So this answer is going to have a 2 involved in it somewhere. We know that 4s and 8s and 16s and 32s and 64s and all those numbers are going to end up having a 2 involved. So 32, the bottom number is the root, the top number is the exponent. Well, what's the fifth root of 32? Can't know. Well, it's going to be something small if I have to do it without a calculator. It's 2. Done. 2 squared is 4. Another skill we've got is to solve some equations. Some of them will be simple, but these are kind of, the first two are kind of setups, because these we've done before. When I'm solving equations, remember I want to think about opposite operations. Well, what's the opposite operations of square rooting something? The opposite operation of square rooting something is squaring something. So I could think of squaring both sides, right? So opposite operation of square is square root, and then I'm left with the answer x equals 36. Now, I want to mention over here, sort of, let me do this a different way. And this is like a setup. Like I said, I'm going to do this a different way. I'm going to think of this as x to the exponent a half instead of the square root. Notice what I did is I squared both sides, right? I squared both sides. Notice that that gives us the exponent x to the exponent 1. Well, that's good, and that gives me my answer, x to the exponent 1. And that's, just put that in the back of your brain. We're going to use this little idea later to get to solve these problems. B, x to the exponent 4, opposite operation of x to the exponent 4 is the fourth root. So I'm going to do the fourth root of both sides. All right, the fourth root of both sides. And I should be able to do this in my head. This fourth root of 4 cancels out, so I'm left with x just like I wanted to. The fourth root of 256 has got to be something small. Notice 2 to the exponent 4 is 16, so it's got to be higher than that. 3's give you some things like 27s and 81s and stuff like that. This has got to be 4, right? And check that in your calculator. 4 to the exponent 4 is 256, and I think it is. Again, second way of doing this, a setup way. This is what we had. We had x to the exponent 4 equals 256. And what did we do? We did the fourth root. Right? The fourth root is the same as the exponent 1/4. And again, notice 4 times 1/4 is just 1. And that's what we have. We have x to the exponent 1. And that's, thinking of it this way is going to become handy in these next problems. So these next problems, I have x to the exponent 3/2 is 125. And how the heck am I going to answer this? Well, this seems like there's stuff all over the place, because I know that 3/2 means the square root cubed, right? So this is what this means, and this is more familiar for me. I know how to get rid of a cube, a cube root. So the first step to get rid of that is the cube root of both sides, right? So I'm going to do the cube root of both sides. That cancels this 3, and then I'm left with the square root of the cube root of 125. Now, how do I get rid of the square root of something? Well, I get rid of the square root of something by squaring it, right? Square it. Those will cancel out, and I'm left with x is equal to, and I haven't evaluated this. I could have. Well, and the cube root of 125 squared. Well, cube root of 125 is 5, squared is 25. This is hard. This is a hard thing to do. But I want to show you kind of a nice way to do this. Can I move this over? No, I can't. I'm going to move it over a little bit, okay, just so I have more room. Hopefully you won't yell at me too much there. Here, essentially I'd like to apply an exponent that's going to sort of cancel out this exponent. Well, I saw over here that this was on both sides the square and the cube root, right? That's the square and the cube root. That's the square and the cube root. Essentially what I could think of this, and notice now I end up, when I multiply exponent 6 over 6, this is x to the exponent 1, and then I just have this on the right. What I've done is I've applied the flip exponent, I'll call it. That's a Restall term, copyright that. Apply the flip exponent. And when I apply the flip exponent, notice that I can skip right to the nitty-gritty, what I really need to do, almost straight off, right? The cube root of 125 is 5 squared is 25. And so this flip exponent that allowed me to get an exponent of 1, multiply those exponents, exponent 1 is much, much faster. So let's think of it this one. Here I've got x to the exponent 2/5, and I've got 4. Well, what exponent will get rid of the 2/5? Well, the flip exponent is 5/2. So I'm going to do that to both sides. Those will cancel out, and I'm left with x to the exponent 1. And on the right side, well, this is just like the questions I had yesterday and earlier in the lesson. I've got the square root of 4 to the exponent 5. Square root of 4 is 2 to the exponent 5. 2 times 2 times 2 times 2 times. So that's 4. Double it is 8. Double it is 16. Double it is 32 is the answer. And of course, you're welcome to check that in your calculator, but you have to show the steps first. How are we doing for time? I think we only have one little tiny example left. You know what? I'm going to do it. I'll be able to do this in less than a couple of minutes. So that's a great looking cow right there. In studies of mammals, scientists have discovered that the formula connects brain mass to body mass. So B is the brain mass, M is the body mass, and we've got some nasty form. Obviously, we're going to have to use a calculator here, right? It's tough to take the 10th root of something. It's tough to do something to the exponent 7. But the idea of this formula is if the mass of the animal was M, its brain mass should be B. It says rewrite the formula using radicals. Well, that means roots, right? So instead of a fractional exponent, I'm going to write this with a root. Well, okay. The 7/10 is just on the M. The bottom is the root. The top is the exponent. There. That's it. Done. B. Calculate the brain mass of a 900 kilogram steer. And the idea there, this is M, right? M is 900. There it is right there. We want to figure out the brain size of this guy right here. What his brain's in there somewhere. What's the mass? Which formula we use depends on how we like to put this into our calculator. Are we good at putting roots into our calculator, or do we like using fractional exponents? That's up to you. That's personal style. So this is hard for me to put into my calculator, so I'm going to use the exponent 7/10 like this, because on the graphing calculator here, then I don't have to hit my math button, right? There's a bunch of stuff from before. 0.01 times 900, and then I can just use I don't have to hit my math key. To the exponent, I do have to put in brackets though. 7 divided by 10, end bracket, 10, end bracket, enter. 1.17 about. And what does that represent? Well, that guy's brain is 1.17 kilograms. The steer's brain was 1.17 kilos. Lastly, last little example here. In Mr. Hoyle's classroom, he finds a 0.5 gram frog brain lying around. That's disgusting. That's a little tiny brain. 0.1 gram frog brain lying around. What was the frog's mass? So notice we've got a couple of different formulas, whichever one we would like to use. And I said I'm partial to this one. So the brain's mass was 0.1. So this is one of these ones where I could rearrange first and then substitute and evaluate, or I could substitute first and then rearrange. And this is completely up to you. What I'm going to do, just because I think the last one I substituted first, then rearrange. I'm going to rearrange first. Okay, so I'm going to solve for m first. Well, how do I do that? I'd love to take care of this weird exponent, but I need to get rid of the 0.01 first. So let's do that. Divide by 0.01. And then what have I got left? Let's have a look at it. It's a bit of a mess. Well, here's one of these fractional exponent things. I want to apply the flip exponent, right? Apply the flip exponent to both sides. The flip exponent is 10/7, right? Flip exponent, so that when I multiply these, I'd end up with m to the exponent 1. Well, flip exponent right there. So the formula for mass of the animal in terms of brain size, this example is just a little bit on the disgusting side, isn't it? And now I can put in my b in there and I'll calculate it, right? I can do it all in one step. Put that into your calculator in one step. Bash away. Remember, to the exponent, it's going to be bracket 0 decimal. This is my calculator steps. Divided by 0.01 to the exponent. Bracket 10 divided by 7, and you press equals, and you get about 26.8 grams of frog before the dissection. Okay, that's it for today.